Hi, my name is Fred Mastropasqua. I'm a Scrum Alliance certified Scrum trainer with Clearly Agile. Today I'm going to talk to you about relative sizing. What is relative sizing, right? What does that really mean? How do we do it? And some pitfalls teams fall into. Let's say that we have 3 empty glasses. And forgive my drawings, let's assume I drew these exactly the same, right? And I have 3 16-ounce glasses exactly the same, and pretend I drew them the same, right? But I have 3 empty glasses. And in these glasses, I put in some liquid, some water. And in this first glass, I put maybe about this much water in there. You know, not too much, maybe a little bit here. In this glass, I fill it about maybe here to here, right? And you can see it's a little, water's moving around, it's a little wavy, so it's not settled. And in this cup here, I put some water, you know, fill it about this high. And I fill this cup of water about that much, right? Now, in these 3 glasses, right, 16-ounce glasses, what I want to ask you is, could you tell me exactly how many ounces of water are in these cups to the exact ounce? Right? You could not, right? You could not tell me exactly how many ounces of water are in these cups. Yet that's what you're asking your team to do when you say, how long will this take you, right? How long will this work take you, right? You're asking them how many ounces of water are in these cups, right? And there we're going to be guessing, right? Sometimes we're close, sometimes we're not close, right? And so what we want to do is relatively size these cups of water, not based on how much water is in there, right, but based on relative to each other, what's the relative size? So let's say I look at all these cups of water and I say, okay, which cup here has the least amount of water in it? All right, well, obviously it's this one. This one has the least amount of water in it. So I'm going to make this at 1x. Okay. If this is a 1x, right, think to yourself, how many x is this cup to this one? All right, some of you might be thinking right now 2x. Some of you might be thinking 3x. Some of you may even think 4x, right? Somewhere in there. So to be safe, we'll go somewhere in the middle. We'll say, okay, maybe it's about a 3x. All right. How many times bigger is this cup to the first cup, right? Relative to the first cup, how many more x is this cup? All right, some of you might think, who knows, 7x, maybe 6x, 5x. Somewhere in there. Someone might even think 8x. So we'll go with somewhere kind of in the middle. We'll go with, let's say it's 6x. All right. About close, pretty close to whatever you're thinking to yourself. All right. But now I've relatively sized these cups of water. Relative to each other, this is what we think. We think this cup has about 6 times more water than this cup, and we think this cup has 3 times more water than that cup. That means we think this cup has about double the amount of water of this first cup. And we might have a discussion. Well, the cup goes wider at the top, so I think that's why it's more, and then we'll come to an agreement. Now, what teams use is they use something called a modified Fibonacci sequence, right? Also known as story points, which was created by Mike Cohn, and we give him credit for that. But the traditional Fibonacci sequence is you take the last 2 numbers in the sequence, and you add them up to the next number in the sequence. So 1 plus 2 is 3. Right? 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13. And here's where you'll start sometimes seeing it what we call modified. So the next number is 21, right? And some teams will use a 20. When Mike Cohn first created this method, he used a 20, so that was the original number. And then sometimes we use 20, some teams will use 21. And then we go to 40 and 100. So we break the sequence, right? We go to larger numbers, and we do that for a reason. We do that on purpose. Because the teams that use these larger numbers, we're trying to show that there's more uncertainty there, right? There's a bigger gap in these numbers to show that we're a little uncertain on our estimates or our relative sizing. Versus down here, the numbers are so close together, we're pretty certain on those numbers. So if your team's using the larger numbers, there's more uncertainty there. Versus the lower numbers, there's a lot more certainty there. So story points here have no association to time. There's no unit measure of time, right, to the story points. It's relative to each other, right? Relative to each other, what number would you do? So let's look at the cups again and let this an example. And where teams struggle with is where teams fall into a pitfall is that they look at these cups and they look at them in isolation, right? They look at them in isolation. All right, so if I look at these here and I cover this up, all right, teams will look at one item in the backlog, or they'll look at this first cup and one thing of work, and they'll be told to say, hey, how many points is this cup of water? Or how many points is this backlog item? Right? And looking at one by itself, there's no way to tell that, right? You have no idea. So you have to create some type of baseline. You can either just pick out a random number, it doesn't matter. Pick this cup is a 5. Okay, if that's a cup is a 5, then we look at the next cup and compare, right? This is where teams, one of the pitfalls teams run into is they just look at an item in isolation by itself. You need something else to compare it to, right? You need something else to compare it to. Then you can do relative sizing. That's what relative sizing is relative to something else. Is this more work, less work, or the same amount of work, right? So we have some relative numbers on here that we've talked about. So if this cup is the one, I'll usually say which item in the backlog is the easiest one to get done. Well, this one has the least amount of water in it. Maybe it's the easiest one. And so we could make it a 1. But there might be something later that comes in that's even less than that. So I want to leave a little room to go down if I need to. So I'm going to make this a 2. All right? You don't have to do that, but I'm creating a baseline. You should at least create a baseline. Okay, now we compare everything to this baseline. This cup of water, we said that it's 3 times more than the first cup of water. So 3 times 2 is what? That's 6. Right? There is no 6. So we'll go up to the next number. We'll go up to the 8. All right, this cup of water, we said it's 6 times more than the first cup, right? So 6 times 2 is what? 12, right? So we're saying it's 12. So there is no 12, so we'll go up to a 13. Right? I just now sized these 3 cups of water using relative points, right? Using relative points. No association to how many ounces of water in the glass, right? No association to time. That is relative sizing, right? That is relative sizing. And again, if the number was a lot higher, the 40s, 100s, then I might know that we might need to break that down. Maybe we take that water and pour it in 2 other cups and size those, relative size those. Another way to kind of think about this is another example is, let's say you were washing cars. Right? Let's say you're washing cars. And so you have a car here. Don't mind my drawings. I'm not a really good car drawer, but there's a car there. All right. My question to you is not how long will it take you to wash this car? Right? That's time-based estimating. Right? Relative sizing is not time-based estimating. What my question is to you is I need to look at the next car and ask you, is this car more work, less work, or the same amount of work as this first car? And you might say, okay, it's the same amount of work. All right, then we'll make this a 1x. And then that means this is a 1x. All right, they're relatively the same amount of work. Doesn't matter how long it takes me. It's the amount of work involved is relatively the same. Let's say that I have over here, I have a van. All right, and I'll say, how much more work is this van than the cars? And we might have a discussion on what that involves. There's more surface area. I got to get up a little bit higher. And we might agree that it's a 2 times. Right? So the van is 2 times more than the car. Again, not how long it's going to take you to wash these cars, but how much more work is involved. Right? Then we get to maybe a bus. Right? Some type of a bus here, a vehicle. And I ask you then, how much more work is this bus than these other items? And we might have a discussion on what all that entails, and we might agree, okay, maybe it's a 4x. I've now relatively sized these cars, the effort it takes to wash those cars, right? And so the question is to the team is not how long, but it's relative size. From this, I can figure out how long it's going to take. Right? If you can do 10 regular cars in a single day, right, then I know that's either 10 cars, 5 vans, or it's 2 buses and 2 cars. Right? We can figure that out once everything's relatively sized. So that's relative sizing. Right? In the next video, I'll show you how you predict time, which you kind of saw a glimpse of that here, using relative size. Right? What's that velocity that the team has?